Let us first have a revision of the basics of electrical engineering. This module is a revision of the basic concepts and terms that are frequently and widely used in the day-to-day working of electrical engineering. I'm sure you all must have learnt about these terms earlier, but we shall go through them so as to have a better understanding of the current relevant context. The concepts are grouped as follows: basic terms associated with AC, terms used for circuit protection, terms used in earthing and lightning protection, commonly used electrical laws and principles, terms used with reference to three-phase circuits, terms used in power utility. The second group has terms associated with alternating current. Firstly, real, apparent, and reactive power for sinusoidal voltages and currents. Real power does the work. Say electric motor takes real power from the source and supplies to a pump, which lifts water to a height. Real power is equal to V into I into cos phi watts or kilowatt. Reactive power establishes the magnetic field. When AC electric energy source is connected to an electromagnetic equipment like a motor or a transformer, the current is utilized to develop the required magnetic field. This part of the current does not do actual work, but facilitates the working of the equipment. The power associated with this current is known as reactive power. Reactive power is equal to V into I into sin phi VARs or kVAR. Apparent power is the capacity of the source. V into I is the capacity of the source, say generator, transformer, etc. Apparent power is equal to V into I VA or kVA. The relationship between kVA, kW and kVAR is as given below. The major aim of any electrical distribution system is to distribute active power which does the work, that is, to run various equipment, machines, etc.
We firstly look at the tender document.
Tender is a document provided by the purchaser or client who wishes to purchase goods or services to the prospective supplier or contractor. Tender is a legal document under Contracts Law 1876 and should be worked with carefully by the purchaser or consultant and supplier or contractors and the engineers. Signing the tender document means contractor has read and understood the conditions of contract, specifications, scope of work, standards, etc., and is ready to execute work as per tender and statutory bindings without compromising quality expected for material and workmanship if work is awarded to him. Hence, it is advisable to understand what is being agreed, and same should be known to the engineers working on the project. The general format of tender includes tender notice, article of agreement, form of tender, project information, scope, fiscal information, general conditions of contract.
Click on each section to view the details. Click next to view more sections of tender document.
Electrical fire. For any fire in residential, commercial, or industrial premises, its cause, unless identified specifically to any other means, is attributed to short circuit in the electrical wiring. This assessment is generally accepted without any objection or doubt, even by a layman, as fire due to electrical faults has become so common and known. This is precisely why one should understand the causes of electrical fire and try to prevent it through proper installation and also through preventive maintenance. Causes of electrical fire. Electrical fire mainly originates due to the following: short circuit or leakage, faults in wiring or cabling or equipment, excessive heating of electrical equipment either due to continuous overload or loose contact, and due to mechanical or electrical failures of switching equipment. Short circuit or leakage faults. This mainly happens due to improper installation and testing of wiring or cabling installation, where either cables or wire insulation is damaged during installation, where cables or wires are of poor quality leading to leakages, or where there is an unnoticed inherent fault in the cables or equipment. Most of our installations are with PVC insulated cables and wires. PVC propagates fire the very moment there is heating due to leakage current or fault due to failure of insulation. This fire causes dense and toxic smoke. Excessive heating of equipment or wiring installation can happen due to either continuous overloading of installation or due to loose contacts in switchgear or at terminals, and improper cable termination. This is very dangerous as such faults brew slowly and heat the surrounding equipments, wires, cables, etc. Fire is ignited due to overheating of metal parts or due to the failure of insulation. Mechanical or electrical failure of equipment can also cause faults due to improper operations due to failure. Such failures, particularly related to switchgear contacts and insulation degradation, go unnoticed if the system is in operation but erupt when switching is done. Air conditioning of buildings is another cause of concern, as the central AC system ducts can propagate fire from one area to another very fast unless proper care is taken.
Pipe or rod earthing. Metallic pipes or rods of appropriate diameter are used as earth electrodes in this scheme. Generally, rods are directly driven in the ground up to a depth of minimum 2 meters. Rods can be 13 millimeters or 19 millimeters in diameter. Steel cord copper pipes are minimum 2.5 meters in length, either GI 100 millimeters diameter or GI 40 millimeters diameter. Longer pipes are used as earth electrode by boring in hard strata where soil resistance is too high to reach the low soil resistance earth. The diameter of the pipe does not make a major difference in earth resistance.
Rule 3 and 5 talk about supervision and inspection.
Rule 3 states that in every registered factory or with every consumer with more than 250 kilowatts connected load, a competent person with a suitable license to operate such a system shall be appointed for the observance of safety provisions laid under the Act and rules. He will inspect the installations, get them tested, and keep a record thereof attested. A list of persons authorized to operate and maintain such plants shall be prepared and will be made available to the inspector whenever demanded.
Generally, the contractor is expected to perform certain fixed duties. Let us look at these. The requirements that need to be fulfilled by the contractor are spelled out in tender conditions. If there are any doubts in the information available, clarifications must be asked from the client, from the consultant, or PMC prior to starting the work. Contractor needs to submit the bar chart clearly indicating the milestones for material supply and execution. If GFC drawings are to be issued stage-wise, the time requirement of GFC drawings should be given in the bar chart as dependency. Expected dates or days for drawings and free issue items delivery should be clearly indicated in the bar chart. Bar chart must consider civil work bar chart and completion date. A typical electrical project consists of, for small to medium size utility input, mostly HT voltage at 11, 22, 33 kV, MV distribution, MV to LV step down with suitable one or more transformers, LT panels distributing secondary voltage of transformers to various subsections of plant through PDBs or MCCs, etc. For large project, utility input at 66, 100, 132, 220 and 400 kV, EHV to MV step down with one or more transformers, MV loads HT motors, MV to LV step down with suitable one or more transformers, and LT panels distributing secondary voltage of transformers to various subsections of plant through PDBs or MCCS, etc. Feeders in each of these distribution stages would have their own VCBs, SF6 breakers, ACBs, MCCBs, protection relays, CTPT, contactors, connecting cables, metering, etc. The installation will be equipped with DG sets of suitable capacities which act as standby emergency power source. Such DG sets may work individually or may have synchronizing facility. Some installations may have captive generation based on steam. Some installations may have rooftop solar power generation. Some critical loads may have UPS systems. IT setups, data centers may have large capacity UPS systems which work in parallel redundant loads. ATS, that is automatic transfer switches, STS, that is static transfer switches too, may be a part of the system. This module introduces a comprehensive single line diagram involving most of these components. Sections are functionally subdivided into 4 subsections for convenience of explanation. These sections are HT wiring, backup systems, distribution systems, and point wiring. The intention is to introduce all the subsections which can exist in any combination in any project. You would understand what to look for in such diagrams as a project engineer.
The first subsection is HT system, which has components as shown on the screen. Click on View SLD to view the single line diagram of a sample installation. Click on Go to Next Slide to explore each component of HT system. This single line diagram shows a typical HT system. Please click on magnifier to view the diagram in detail. Each of the subsequent slides shall take you through individual sections of this diagram. The flow of information will be general information, installation, and testing, commissioning and maintenance. Click on the button to see the details.
HT supply. The grid supply voltage level available from DISCOM for various load ranges is as per grid code. The load range may change from state to state or as per the HT, EHT voltage available nearer to site as a special case. General information. Supply agency provides supply at voltage levels based on the load as per grid code. Load up to 1500 kV amperes on 11 kV. Further load up to 5 megavolt amperes on 22 or 33 kV, and load above 5 megavolt amperes on 132 or 220 kV. However, in urban areas and industrial areas, loads more than 5 megavolt amperes can be supplied at 33 kV based on the infrastructure available. Supply can be made available by overhead lines or by cables. Overhead lines are a cheaper option but need space and right-of-way for installation. For EHV, tower lines are essential, but cables are also available. Overhead lines or tower lines can be single circuit or multi-circuit. Tower lines up to 4 circuits have been designed. AC lines up to 800 kV are already in use, and further voltages up to 1200 kV are being tested. Supply company may give such connection from a nearby tap-off or as an express feeder depending on the requirement of the project. Express feeder will ensure a dedicated breaker for the project in supply company substation. This ensures extra availability of the supply as it does not get affected by faults on nearby loads.
Installation. Overhead lines up to 33 kV are either pin mounted or suspended. Long distance lines are usually suspended. Cut points and stay sets are needed at appropriate points for stability of lines. Proper sag needs to be given for all overhead or tower lines. All poles need to have proper foundation using proper grade cement concrete and need to be earthed. Pin insulators are available up to 33 kV class. However, disc insulators are 11 kV class and multiple disc insulators need to be used based on the voltage. Proper hardware here is essential. Stringing of conductors has to be done using proper equipment. Improper stringing can lead to twisting of poles. EHV cables need to be laid at least 1500 mm below the ground level and need to be protected properly to avoid mechanical damage. HT or EHV cable installation needs to be executed by skilled and trained jointers using proper straight through end termination kits. Proper trefoil arrangement needs to be used when single core cables are used.
Testing, commissioning and maintenance. Cables need proper testing after jointing is done. It will include pressure testing, insulation resistance, continuity and physical inspection for sheath damage. Insulation resistance must be 50 mega ohms or higher. Overhead lines need to be tested for insulation resistance with 5 kV megar. This will detect any faulty insulator.
Each of the subsequent slides shall take you through individual sections of this diagram. The flow of information will be general information, installation, and testing, commissioning and maintenance. Click on the button to see the details.
LT cables and wires. LT cables and wires are usually 660 or 1100 volts grade. LT cables are available in both aluminum and copper conductor, armored, unarmored, shielded, and in 1, 2, 3, 3.5, 4 core. Multi-core cables beyond 4 cores are also available against order. PVC is used for insulation and sheath, but cables are also available in XLPE insulation and PVC sheath. XLPE insulated cables have more current carrying capacity as cable can withstand higher temperature. Small cables up to 4 square mm are available in solid conductor, but multi-strand conductor cables are preferred. Flat strip armored and round wire armored cables are available. Armored cables are provided for mechanical protection. Armored cables are less flexible. Supply agencies such as NSEDCL prefer round wire armored cables. LT cables and wires are selected for total current rating required and then fault level, laying methods, temperature. Derating factors have to be applied based on the ambient temperature above 40 degrees Celsius and method of installation. If it is in ground or in troughs or in direct air, derations are different and are recommended by standards. Derations also apply for multiple parallel runs of cables and for cables laid side by side within 150 mm of each other. For standard cables laid in ground, 2 cables touching each other and 40 degrees Celsius ambient, derating is around 0.8. Voltage drops become important when loads are larger and lengths of cables are high, say 200 meters or more. Voltage drop in any section needs to be limited to 3% with total voltage from drop source to load less than 5%. Number of runs or size of cable needs to be increased to keep voltage drop within limits. For critical and life safety loads, ERLS cables are recommended. Shop testing is not witnessed except for very large quantities. However, physical inspection, high voltage test, insulation resistance, and conductor resistance test need to be conducted during shop testing. Type tests certificated as per IS 1554 are essential. FRLS or ZHLS cables are subjected to flammability test, smoke generation, and oxygen index. Continuity test and insulation resistance test must be carried out after installation.
This module shall mainly cover diesel generator sets and uninterrupted power supply systems. Let us first try to understand in brief the need for backup and emergency supply systems. Backup or emergency supply system. Critical loads like life safety equipment, emergency lighting, lifts, operation theaters in the hospitals, servers, etc. need backup and continuous supply due to the criticality of operation or financial losses that may incur due to loss of power. Diesel engine generator sets are used for backup or standby power. However, where break-in power is not acceptable, uninterrupted power supply, that is UPS, is used. UPS has storage batteries as backup source of power. DG sets can produce long-time power backup, but UPS backup time depends on the battery capacity and is limited, but there is no break-in supply. In this module, we will learn a few critical things about the backup power systems.
Let us begin with Section 1. Diesel generating sets. Generator sets with diesel engines as prime movers are main backup power sources for electrical systems, commonly called DG sets. Alternatively, gas engines which operate on CNG or PNG, biogas, and high-rating engines which work on heavy stock oil are used for backup source or for captive generation. Generally, diesel engine generators are not used for captive or continuous power due to high per-unit costs unless there is no alternative. Per-unit costs for other options mentioned above are much lesser compared to diesel-based generation. However, captive systems can be effectively used for base load supply where loads are fairly stable and standby systems are required as yearly maintenance period is longer. Comparatively, starting-stopping of DG sets is easier and regular maintenance periods are much lesser. Hence, we will concentrate here on diesel engine generators. And servers, continuous process industries, and electrically operated life-saving equipment, it has become essential to provide uninterrupted power supply for all above applications so that there is no break even if mains power fails for short time when DG sets are switched on or when mains power is restored. This has become a functional requirement to save downtime and also material in case of continuous process industries. For most of such critical applications, battery-backed static UPS systems are provided, though alternative systems like rotary UPS systems, motor generator sets, etc. are available.
In this module, we shall look at the following aspects of point wiring: classification of point wiring, methods of point wiring, conduits and accessories, wires and cables, switches and sockets, layouts and controls, wiring for data centers and workstations, and installation and testing.
Switches and sockets. Few years back, porcelain-clad switches and sockets were predominantly used in both surface and concealed versions, which were later replaced by piano-type switches. Piano switches are still used in low-end and rural housing due to lower costs, but in most of the places now, modular switches are used due to aesthetics, reliability, and ease of installation. Most modular switches available meet the quality requirement and manufacturers offer 10 years or lifetime warranty. All of them come with surface or cancelled ABS or metal boxes and switch plates. Selection of colors and finishes is available. Hence, selection of switches and sockets is mainly on the finish, color, and cost. Switches are available up to 20 amperes and also in two-way bell push versions with or without indication and markings. Sockets are available in 2-pin, 3-pin and 5-pin versions with standard round pins, flat pins and universal configuration. Ratings are available from 5 to 6 amperes to 20 amperes.
As per IE rules, sockets must have earthing pin, hence 3 or 5 pin sockets should be used. Avoid using 2-pin sockets and plug tops. Sockets with 2P, 2P plus E, 3P, 3P plus E, 3P plus N plus E configuration are also available in metal clad version and in ABS plastic. These can be with interlocked plug tops or isolators. These are mainly used in industrial environments, labs and utilities and use either MCBs or RCCBs for switching. These are available in ready-made boxes too.